Okay, which statement matches which graph? Well, what have we got? Let's look at the first statement. Y is directly proportional to X. Well, it's got to be this one, hasn't it? When you've got a direct proportion relationship, directly proportional relationship between Y and X, it's a straight line. So it's got to be that one. So we can write that in, that's D, straight away. Okay? Right, next one. Y is inversely proportional to X. Okay. Well, these two catch the eye. It's not going to be that one, because when you have an inverse relationship, you've just got to kind of know that you get this sort of shape in the plus y and plus x region, okay? So it's going to be one of these two. But which one? Well, y is inversely proportional to x. So it's saying that y is some constant times 1 over x. Let's just pretend that the constant is 1, okay? Let's just write, just to make our life easy, there are no numbers on here, it's fine. Y is 1 over x. So that means y is inversely proportional to x. Okay, now if x were, I don't know, 5, then y is a fifth, okay? So if x is 5, y is a fifth. So x is big, y is small. That fits. That's where this shape comes from. But what if x was negative? Were negative? What if x were minus 2? Okay? If x are minus 2, then y is minus a half. Which means that when x is negative, y is also negative. So it must be this one. Because here, y is never negative. Y is always positive. Y is positive in these two regions here. And y is negative in these two. So when y is inversely proportional to x, it's possible to have negative values of x and negative values of y. So it must be this one. Because here, y is negative and x is negative, and here y is positive, x is positive. So that one is A. Okay? Right, next one. Y is proportional to the square of x. So it's saying y is proportional to the square of x. Again, I'm going to pretend that the constant of proportionality is 1. It doesn't really matter for this question. So in other words, y is x squared. Well, straight away, it's got to be that one. You need to remember or learn that the shape of y equals x squared is that. Okay? You can put in some numbers to convince yourself. When x is 1, 1 squared is 1. Okay? So when x is 1, y is 1. 1, 1, okay. When x is 2, 2 squared is 4. So when x is 2, y is 4. When x is 3, y is 9. X is 3, 9 is up here. And that's y, so 9 up there somewhere. Okay? That's why it has this shape, this curved shape, because as x gets bigger, y gets bigger much quicker, because you're squaring it to get y. You're squaring x to get y. So that's why it has this sort of that shape. Okay, so that, B, has to be that one. And finally, just by elimination, y is inversely proportional to the square of x. Well, we know it's going to be C, because we haven't made a mistake. But I'll explain why this graph, this shape, shows you that y is inversely proportional to the square of x. Okay, in equation form that means y is inversely proportional to the square of x. Again, doesn't matter about the constant of proportionality, let's just pretend it's 1. So in other words, in simple terms, y is 1 over x squared. That's what that sentence means. So, when x is positive, here, let's say 5, okay, y is 1 over 5 squared, which is 1/25. So y is also positive. It's small, but positive, okay? So when x is 5, out here somewhere, right, y is a 25th. So that value would be a 25th. That's fine. And again, let's just pick another value for x, just to hammer the point home. When x is 2, say, okay, y is 1 over 2 squared, y is a quarter. All right, so that would be a quarter there. So, when x is positive, y is definitely positive. So that's where this bit comes from. But what about when x is negative? What if x were minus 2? Okay, then y is 1 over minus 2 squared, which is 1 over minus 2 times minus 2. Minus times a minus is a positive, so it's 4. So again, it's a quarter. So when x is minus 2, y is a quarter again. Same values when x is 2. And it's the same for when x is minus 5. Okay? When x is minus 5 squared is 25, so you get y is a 25th again. Okay, same value. So it's symmetrical about the y-axis. So it's impossible for y to take negative values for this last one here. No matter what the value of x, whether x is positive or negative, y is always positive. And therefore, this one corresponds to that. It's a difference between these two. Okay? For this one, y is inversely proportional to x. Here, when x is negative, y is also negative, which is why it's in these two regions. But for this one, here, when x is negative, y remains positive, so it's in these two regions. There you go.